So on 15, I asked you to copy these ones down. And so our goal here is to prove whether or not the two lines in question are parallel. Okay? And sometimes you're going to have to do a little bit of extra work on the side. Okay, so for example, here, you're given two angles, but we don't have a name for that particular pair. Okay? We don't. So I'm going to do a little bit of extra work. If this is 110, I know that this is 110 as well. I use the vertically opposite angle property, knowing that vertically opposite angles are congruent. They're the same, no matter what. I can use that one. Okay? Now I see that consecutive interior angles, they add up to 180. Okay? Therefore, AB is parallel to CD. That's a very short justification for that. Morning. Down the road, I will give you a little table, and you may have to show me a bit more, like a more formal way of indicating this. But that's kind of how you would prove whether or not lines are parallel. Is this all I need to do here, guys? Is this all, would this be enough? And the answer is yes. Remember the four? The four we have a name for. There's consecutive interior, there's alternate interior, alternate exterior, and corresponding. If you can prove one of them is true, then you can tell everybody that AB is parallel to CD. Okay. Let's do this question over here. Do we have a name for these two? Study sheet. Do we have a name? Corresponding? Yes, corresponding. So what I will do is corresponding, can you see that? Corresponding angles are congruent. And I will, in brackets, tell everybody we're talking about the angles that measure 79 degrees. Therefore, so we have a name, and we see that they're congruent. Okay, guys? We have a name, and we see that they're the same. Therefore, AB is indeed parallel to CD. Keep going. Over here. Do we have a name for these two here? They look corresponding, don't they? But they're not. And one thing you have to be comfortable with is that any lines that are in between the two that we're interested in, you have to ignore. You have to ignore anything that's happening in the middle. Just focus on these two intersections, this one here and this one there, okay? Those are the only two intersections you're interested in right now. These are both exterior angles, okay? So it doesn't really help us a whole lot. What can we do? One thing that I'm going to do is, if this is 130 here, what's this one right next to it? This one would be 50, correct? Because there's a straight angle there. So I will write that down. Straight angle is equal to 180. I'm justifying my work there. Straight angle is 180. I know it's a little small. I apologize for that. And now, do I have a name for these two? What are they called? The two highlighted ones. Alternate. Every time, okay guys, I know this is early in the morning, right? You're still waking up, but if this is a transversal, every time they're on opposite sides of the transversal, we use the name alternate, okay? And in this case, they're both outside. So these are considered alternate exterior angles. So we have a name for them. So let's start this. Alternate exterior angles. Are they the same in this case? They're not. So what we do is we use that congruent symbol, but we cross it out. If you don't like the symbol, you can just write they're not the same. I'm okay with that. Okay, alternate exterior angles are not equal, they're not the same. Therefore, what are we going to say? AB is not parallel to CD. So if you like symbols, it's actually not a whole lot of writing that you will have to do. Okay? So here we had to do a little bit of extra work. We had to go into our toolkit. Toolkit is what? Triangle, four-sided, vertically opposite, straight angles. Those are our toolkit angles that we can go and get. Okay? Okay, keep going. This one. I'm going to zoom into this one here. Wow, that's a lot of stuff going on. But remember, you're just interested in these two intersections here. Okay, and in particular, let me highlight the transversal. If you can do the same. This is the transversal I'm interested in. Kind of looks weird sideways, right? Let me turn that a little bit. Do we have a name for these two? They're alternate something, but one is interior, one is exterior, so we don't have a name for that. We need them both to be inside, so if we had these two, we would have a name for those. If we had one out here and one out here, that would be alternate exterior. Okay, so we have to do a little bit more work here. Do we have a name for these two? If we had these two, did we have a name for those two angles? CIAs, right? So why don't we, I'm going to choose this route. You can choose any route you want as long as you're consistent. This is 119. And the reason I use that is, let me turn this guy, sorry. This wasn't a good diagram, was it? It probably happened on Friday, right? Just before we went home. So I'm just going to say vertically opposite angles. Vertically opposite angles are congruent. That's the property I used there. And what are these ones supposed to add up to if lines are parallel? They're supposed to add up to 180, but you can tell that they don't. It's 179 if you add these up. Okay? So we will say this. This is my conclusion here. Consecutive interior angles are not equal to 180. Therefore, AB is not parallel to CD. You write it anywhere you can, okay? Like, if this is throwing you off, writing it sideways, just write it underneath. And what I'm going to do here, if you do the same, if you like highlighting, I'm just going to highlight consecutive interior. And I'm just going to show myself, okay, this one and this one is the one we're talking about. Okay, those two, which you have a name for, do not add up to 180. Consecutive interior are the only ones that add up to 180. The other three, they are equal to each other. But when they're like this, we're checking for, do they add up to 180? Okay. All right. Pause there. And I'll gladly help you, okay? So in this case, we're told lines are parallel. That's not what we're trying to show here. Once lines are parallel, we can assume that the four names, right? Those four names we have, that the properties are true for those. These are CIAs, right? That one and that one. There's CIAs. And they're supposed to add up to 180. So what I will do is I will take this angle. So I will go x plus 109 And I like to think of it as this is an angle in brackets, plus this other angle, x plus 89, is equal to 180. Right? Those two angles combined add up to 180 degrees. Since there is no negative in front of any of the brackets or no other number other than 1, I can get rid of the brackets now. I can just go x plus 109 plus x plus 89 is equal to 180. I will combine my terms, my like terms. So x and x turns out to be, if you go underline that, that's 2x. The plus 109 and 89, that adds up to 198. And I have 180 on the other side. At this point, I bring stuff over. So I want all my variables on one side and all the constants on the other side. So I'll take this bundle, this term, and bring it over to the other side, leaving me with 2x is equal to 180 minus 198. Clean it up a little bit. This would be negative 18. You divide both sides by 2. X is equal to negative 9 degrees. So now you've solved for x. Okay. So I'll do that. How about we do 27 real quick? We'll do that together. 27 is right here. I already started it. These two angles, these two are called corresponding. And we know that corresponding angles will be equal to each other, right? Whatever that measure is. These are equal to each other. So 6x is equal to this angle, which is expressed by 5x plus 10. Okay? So this is your initial setup. One is equal to the other. There's no 180. Do you see it? There's no 180 on these ones. It's only CIAs that you have this plus this is equal to 180. All right. I have everything combined for the most part. If I just look at this side, there's only x and a constant. I look at that side, there's only x. So I can't do anything on either side as is. I don't need to clean up. So I take the 5x, bring it over to this side. So 6x minus 5x is equal to 10. You subtract these, you get x is equal to 10. You are done. So sometimes there's very little algebra you need to do. And if you don't like the bringing over stuff, think of it, I know some teachers probably told you whatever you do to one side, do to the other. So if you want to go minus 5x, like you take 5x away from both sides, it will cancel this out, but you still end up subtracting 5x on the left side no matter what. It's still the same concept, just a different approach to it. Okay? Let me do one more. Well, the rest, I think you're okay with that. So I'm just going to stop there for now. It's like a homework check.